worksheet number 12, specifically questions 2, 4, and 5 on worksheet number 12. Number 2 says, how fast must an electron be traveling through a magnetic field of this value if it follows a circular path of 6.5 times 10 to the negative 2 meters? Now, it doesn't actually say the charged particle is moving perpendicular to the field, right? It doesn't say so in so many words. How do we know the charged particle is moving perpendicular to the field and that the equations that we've learned about are valid? How do we know that in this question, even though it doesn't say it in so many words? Yeah, it goes in a circle. If it's not perpendicular to the magnetic field, then it's not going to go in a circle, right? So everything we've learned is good here. Listen, you're going to get one of two questions. It's either perpendicular or it's parallel. If it's parallel, it's not even going to be deflected, let alone go in a circle. So you know that it has to be perpendicular here. We're going to say, for this question, FC equals FM. Now, we're allowed to say F is equal to QVB. We're allowed to see F is equal to mv squared over R. But generally speaking, when you've got a question that says the word radius in the question, in this context, you're going to use FC is equal to FM. That's at least what we're going to try first. And if it doesn't work, then we'll try something else. So FC is mv squared over R. FM is QVB. And we can cancel one of the V's because it appears on both sides. One V there, one of the V's there. Left with mv over R equals Q times B. Now I want to solve for V. Let's get rid of the R first. How do you get rid of the R? I didn't understand that. Yeah, you multiply it. So we get mv equals Q times B times R. And then we're going to solve for V. How are we going to get rid of that one? Is it that? Yeah. We're going to do the m down by dividing, right? I can understand the Matthew language. That's what he meant. QVR over m. So we're going to say the charge of the electron is 1.6. It's actually negative, but as you know, we always drop the sign. B is 3 times 10 to the negative 3. Is that a strong, weak magnetic field? And the Earth is 10 to the minus 5. A bar magnet is usually 10 to the minus 2. So I'd say kind of weakish, but kind of in between, right? R, 6.5 times 10 to the minus 2. Divide that by mass of the electron, 9.11. What do we usually get a speed to be? Anybody remember that? The range is usually 10 to the 5, 10 to the 6. Could it be slower than that? Yes. Could it be faster than that? Yes. Okay, and this one, we get 3.4 times 10 to the 7. Does that seem reasonable? Yeah, it's not bad. Like, it's faster than we usually get, but it's certainly in the realm of possibility, right? If we get 3.4 times 10 to the 8, we're wrong, because it can't be bigger than 3 times 10 to the 8. 10 to the 7 is absolutely possible. It's just not as common as 10 to the 5 or 10 to the 6. That's all. We good there? Okay, let's take a look at number 4. What's the kinetic energy in joules and electron volts? We'll worry about the units later. Of the path of an alpha particle that moves through this magnetic field and follows this circular path. We know that, once again, we see this radius thing here. So we're probably going to do the FC equals FM thing again. We're going to say mv squared over R equals QVB. One of the V's cancels. The only thing I don't have here is V. Becomes QBR over M. So Q, this is an alpha particle. Be careful there. Charge of an alpha particle is 3.2. Good. Another common mistake in this is just getting in the habit of using an electron, right? We use an electron so often that sometimes we see an alpha particle and we forget to change the charge to 3.2. B is 1 times 10 to the negative 1 Tesla. Is that a weak or a strong field? That's pretty strong, actually, right? Magnets are about 10 to the minus 2, so about 10 times stronger than a bar magnet. Still not crazy strong, but R, 0.025 meters. Divide that by the mass of the alpha particle. Again, be careful about that number. We solve for V there. We end up getting a speed of 120,300.75 meters per second. Is that reasonable? 1.2 times 10 to the 5. Yeah, it's right there in that range that we expected. That's not what I was looking for, though. What am I trying to find here? Kinetic energy. If you're looking for kinetic energy, then why don't we just do what we do in physics 20? In physics 20, we said a 1,000-kilogram car travels down the highway at 25 meters per second. What's its kinetic energy? Well, here we got an alpha particle that's traveling down the highway at 1.2 times 10 to the 5 meters per second. What's its kinetic energy? It's the same thing. Numbers are a little harder, but don't forget to square that. When we solve for the kinetic energy there in joules, we get 4.8 times 10 to the negative 17 joules. So we're done part of this question. Kinetic energy is 4.8 times 10 to the negative 17 joules. You guys remember how we talked about this for our last unit assignment, right? How to convert joules to electron volts? On your data sheet, it says 1.0 EV is equal to, I think it says 1.00 EV actually, is equal to 1.60 times 10 to the minus 19 joules. So if you want to do that conversion, let's do this. Let's say 1 EV is to 1.6 times 10 to the minus 19 joules, as X EVs is to 4.8 times 10 to the minus 17 joules. So 1 is to 1.6 as X is to 4.8. Take the 4.8 up by multiplying, and we get a value for X of 300, or 3.0 times 10 to the 2 EVs. How many people got the EV? How many people got the joule part of that? Okay, how many people get the EV part of that? Not as many. This is fair game now, right? Like we've done this a few times now, not a ton. As the year goes on, we'll do it more, but we've done it enough times that you can do this now. So EVs is fair game, and I can't remember, to be honest, if EVs appear on your unit test. It's coming up, by the way, next Tuesday. But be prepared for it, because it's fair game. Whether it's there or not, it's fair game. And finally, number 5. How does the radius of curvature of an electron's path compare to the radius of curvature of an alpha particle's path moving through the same magnetic field at the same speed? Remember what we said on Friday? The word compare means? Okay, if we look back on our little dictionary / thesaurus at the back of the room, compare means the same thing as ratio. If I want to have a synonym for compare, a ratio is a synonym for compare. Another word that means the same thing as both compare and ratio is divide. When you want to compare two things numerically, I don't want you to subtract them or just say, oh, this is 1 and this is 7. Like, divide them. You want to compare, the analogy that we used on Friday, my age to your age? Divide my age to your age. You want to compare your age to my age? Divide your age by my age. We want to compare the radius of the electron's path to the radius of the alpha particle's path, then divide radius of the electron divided by the radius of the alpha particle. Now, that would be easy if we knew what those two radii were, right? If the question said, here's the radius of the electron's path, here's the radius of the alpha's, compare them, this would be an easy question now. But we don't know what the radii are. And I don't even think we can find a value for them. So what are we going to do? Well, we don't have a number for either of these things. Then let's sub in an expression. We know that FC is equal to FM, and therefore mv squared over r is equal to qvb. V's cancel. R goes up by multiplying. R ends up being mv over qb. So we take the r up by multiplying, the qb goes down by dividing. Okay, so r is equal to mv over qb. Does that make sense? All right, we still don't know a value. Okay, we know the mass of the electron, we know the charge of the electron, but we don't know what V or B is. So here's what I want to do. I'm going to actually just color code this. I'm going to say RE over R alpha. The radius of the electron's path is ME VE over QE times BE. Does that make sense? MV over QB for the electron. I know a couple of those numbers are, but not all. That's okay. That's okay. You'll see in a minute. Divided by, well, we're going to say M alpha V alpha over Q alpha times B alpha. Good? Now, there are two things actually that I can cancel out here. It says it's the same magnetic field. Same magnetic field, all right. Same magnetic field. Let's cancel out the magnetic field then. Also says it's the same speed. All right, then let's cancel out the speed. So now I've got ME over QE. Well, I can divide by M alpha over Q alpha, or I can times it by Q alpha over M alpha. Does that make sense what I just did? Divide by a fraction there, I multiply by the reciprocal. I didn't even need to do that, but just did it to simplify it a little bit. Now, we know the numbers for these, right? If you sub in all these numbers, great. Do the math. Now, there is a little bit of a shortcut here, actually. A little bit of a shortcut, it's not much, but we can say, I'm going to show you the shortcut here. If you don't like it, that's okay. Just sub in the numbers here and get the ratio. The mass of the alpha particle, the mass of the electron divided by the charge of the electron times the charge of the alpha particle, is it not twice the charge of the electron? Divided by the mass of the alpha. So if we cancel out that, it ends up being 2m times E over m times alpha. Make sense what I just did there? You didn't need to spot that shortcut, right? Just sub in your numbers. When you do that, you end up getting a value here of 2.7 times 10 to the negative 4. So you want to compare these two? Well, we'd say that the radius of the electron is 2.7 times 10 to the negative 4 times the radius of the alpha particle. It's just like saying on Friday, the mass of the teacher, the mass of Mr. Dickie, is 2 times the mass of the student. Right? When we compared, sorry, not mass. I'm not twice as heavy as you are. The age of the teacher was twice the age of the student, not mass. The age, right? 36-ish, 18, okay, means the ratio is 2 to 1. Or to compare them, we'd say I'm twice as old as you. Or we'd say to compare the radius of the electron's path to the radius of the alpha particle's path, well, it's 2 times 10 to the negative 4 times the radius of the alpha particle's path. Is there a hand up back here? Yep. I crossed off B because it says it's the same magnetic field and the same speed. So I crossed off V because it appeared in the numerator in the top equation and the numerator in the bottom equation. So it appeared on the top and the bottom. I crossed off B because it appeared in the denominator of the top and the denominator of the bottom equation. So in other words, it appeared on the top and the bottom. And because it's the same value, even though I called it something different there, because B is the same value on the top and the bottom, it's fine to cancel it. Okay, does that make sense?
You just said multiply instead of dividing